Okay guys, today we're going to talk about the science of chemistry. We're going to get into some basic stuff with it. We're going to get stuff that you've seen most of it since probably 6th or 7th grade. But we kind of got to get the basics before we can actually get to the next level. Okay, so that's what we're going to start on today. And a couple of terms that you have heard over and over and over again. Again, real simple, real straightforward. But what is chemistry? What do we mean by the definition for chemistry? It must be something very difficult, right? But if you start looking at it, you go, okay, what is chemistry? Well, we're talking about matter and stuff and probably what's going to happen with it when we mix the things together and see if anything blows up. That's what usually people think of when they think of chemistry. Well, if you define chemistry, it's the study of the composition, what stuff is made of, right? The structure, what it literally looks like, and the properties of the matter in the universe and the changes that it undergoes. Okay? Pretty straightforward, pretty simple. Okay? Now, for example, up here, you see this picture right up here. This is a picture of one of those heat and oil lamp things that you use to cook food over, you know, in butane lighter kind of deals. That's what that is. You can, again, barely see it, but there's a flame coming out. Well, what you're actually doing is you're burning a material, in this case, ethanol, with oxygen, and it's producing carbon dioxide and water as a byproduct, but it's also producing energy. And the energy, obviously, you see in the form of the flame. Okay? So that's the basic idea of what chemistry is. Now, two words that kind of have meanings that are somewhat reciprocal of each other. One kind of answers the other. And that's the annoying thing about these two definitions, is one actually does answer the other one. Okay? What is matter? Okay. Most people are like, what is matter? Well, you mean what stuff is? Yeah, what is it? Well, if we define it scientifically, it's actually really easy. It's anything that has mass and takes up space. Now, again, that is pretty straightforward, isn't it? Anything that has mass and takes up space is considered matter. So this right here is considered matter. The tabletop, the camera that we're using, the air that you breathe, the soda that you drank yesterday, everything around you that you can see, feel, hear, and taste, and touch is basically matter. Now, okay, so a part of that definition is the word mass. Well, what is mass? A little harder to define, isn't it? But if you look at it in terms of what it is, it's the measure of the amount of matter, how much matter you have, okay? So it's the measure of the amount of matter that you have in an object, okay? How much you got. So if you look at those two definitions, they actually really quickly kind of tell each other. Anything that has mass and takes up space, well, what's mass? How much matter you have. And see, they kind of reciprocate, they kind of tell each other's definitions. And it's kind of an annoying idea, but it does work, and it does kind of explain both of them. Now, what if we go to the next step and look at two other words? The word atom and the word element. Okay, what's the difference between those two? Well, an atom is the smallest unit of an element. Okay? The smallest unit of an element that has the properties of that element. So again, that's going to tell you something real quick. It's going to tell you it's the smallest stuff that still has all the characteristics of stuff. Okay? If you want to get simplified. But then you see the word element in that definition. Well, then the next question is, okay, what's an element? Well, an element is a pure substance. So it's only one kind of thing made up of only one kind of atom. That's an element. And again, we know this because we have these wonderful things called periodic tables. Okay? The periodic table of elements shows us all the elements that we have discovered. And again, you already know that there are over 100. There's actually 118. And that's still in a state of change right there, how many elements we have. Okay? So, there's this old periodic table, which obviously is not a newer one, updated one. Y'all know mine. Mine has all 118 with all their names, and they're still playing with some more even after the 118. But those aren't quite there yet. So once they get there and they give them official names, then we'll put them on our periodic table. Okay. Now, so that's an element, right? They again have those definitions that are kind of reciprocal of each other, somewhat. Now, what then is a compound? Well, a compound is a substance that is made up of different atoms of different elements. Okay, at least two. Okay, you can't have a compound with one element in it. That just doesn't make sense. So it's made up of two or more atoms of different elements. Chemically, that's the key word, chemically combined. They're not physically mixed together, they're chemically bonded. So you can't break them apart just by regular means, okay? And an example I give is sucrose. Now you may or may not have heard of sucrose. Sucrose is table sugar, okay? Table sugar, you've all got it at home probably. Its formula is C12H22O11, so it's got 12 carbons, 22 hydrogens, and 11 oxygens, okay? When you look at it, that's the actual formula model, ball and stick model of what the molecule looks like. And again, the white ones are hydrogens, the red ones are oxygens, and the gray ones are carbons. But that's what it looks like if you could magnify it really big, and we can't obviously, because we don't have anywhere near the technology to do that. There are places that can, but we're not going to do that. But you see, it's a really complex molecule, although in reality it's a very simple molecule compared to all the other ones. But anyway, so that's a compound. Anything that has two or more atoms of different elements chemically combined. They're bonded together, okay? Now, when we talk about matter, guys, I want to real quick look at two basic properties of matter. Matter has two basic characteristics that you can look at, okay? And you've never heard of this, I'm almost positive, because this is something fairly new. All right? The first kind of property is called an extensive property. Now, what in the heck does that mean? Well, it basically means how much matter you have can be affected, okay? Can affect this property. So how much matter you have actually affects this property. So, the more you have, the more this property of this matter changes. The less you have, it changes even differently, right? So how much you have affects this extensive property, okay? Volume, duh, right? I mean, you know, makes sense, right? The more you have, the more space you're going to take up. 1 gallon versus 100 gallons of water, the 100 gallons is a lot more volume than the 1 gallon. It's going to take up a lot more space. That's because you have more of it. And then obviously mass is the second one. The more mass I add, the more I pour, the more material I have, it's going to change that extensive property. Those are constantly changing. Now the last one I wanted to mention is one that most people don't really understand until you throw it in their brain. Oh, this is what this is. Most people don't really think of this one. And it's called energy content. How much energy this matter has in it. Okay? Now, primary example is calories. You know, the average human being is supposed to eat about 2,000 to 2,400 calories a day of food. Okay? Well, if you ate 4,800 calories worth of food, you've eaten more food than your body would normally burn. Okay? Well, that's because you've eaten more food. The more food you eat, the more calories you have. Right? I mean, you eat one sandwich, that's 350 calories. You eat 2 sandwiches, that's 700 calories. That's because you've eaten more matter. And that's a extensive property of matter. The obvious example then, obviously opposite of that is an intensive property. These are properties that I don't care how much matter you got, okay? I don't care how much you got, it's not going to affect it one way or the other, okay? It doesn't affect it one way or the other. You can have a little bit of it, you can have a huge amount of it. And again, I'm going to go back to a bottle of water. Where's some water here? Here's my water that I'm going to use later, although it's not true water. But this water right here, right? I can have 100 gallons of it. I can have this much of it. These factors will not be affected by how much I have. Okay, it doesn't really matter. And two of them should make sense really quickly. Number one on the list, the melting point. The melting point of a substance, it doesn't matter if you got a milliliter of water or a Olympic-sized swimming pool full of water. Water is going to change its shape, not shape, whether it's going to be a solid or a liquid at the same temperature. By the way, that's 32 degrees Fahrenheit or 0 degrees Celsius, right? It's going to change those things. If I am a piece of ice and I get 32 degrees and above, I'm going to melt. I don't care if I got a little drop of ice this big or I've got a lake full of ice. Now, obviously, more of it takes longer for it to melt, but at that temperature, melting starts. Then obviously you have boiling point. The boiling point of water, again, whether you have a milliliter or an Olympic-sized swimming pool of it, is going to start to boil at the same temperature. Once that water hits that temperature, it's going to boil. That's 100 degrees Celsius, or for us in Fahrenheit land, that's 212 degrees Fahrenheit. Okay? And then the third one I want to mention, also, it doesn't matter how much you have. Water, whether you have a little bit or a lot, and I'm just using water as an example, its density is always the same. About 1 gram per milliliter. It's about 1. Again, don't care if I got a gallon of it, 5,000 gallons of it. If I got an ocean full of water, it's still going to have the same density. Okay? Now, those are extensive versus intensive properties. Really straightforward, really easy, right? But again, you probably never heard those before today. All right. Now I want to look at some physical changes here, right? Because we've been talking about chemicals and atoms and elements and compounds. Things change. Duh. And what we want to do is we want to look at the differences in the two basic types of changes. You can either have physical change or you can have chemical change. Okay? We want to look at the physical one first. Okay? A physical change does not involve a change in the identity of the substance. Okay. If I take this paper towel and I fold it up, and I fold it, and I fold it, and I fold it, I have changed its shape, haven't I? But it is still a paper towel. It still has all the characteristics of a piece of paper towel. If I take this paper towel and I start to shred it into 100 pieces, right? There we go. It's still a paper towel, right? Now it's in little pieces, but it's still a paper towel, right? Okay, good. We got that. Now, the most common physical change, obviously, that we think of when we think of physical changes is phase changes. Going from one state of matter to the next. Okay? And we won't do that real quick. We're going to look at those particular things right now. There are 4 different phases, and I hope you already know this from physical science. There's 4 phases of matter. Solids, liquid, gas, and plasma. Okay? Solid, liquid, gas, plasma. Now, what is the difference between a solid, a liquid, and a gas, and a plasma? Well, it's actually very simple. Solids, you know, right? Solid, right? Solids have a definite volume and a definite shape. Like here in this little glass jar here. I got a solid. Now it's a powder, but it's still a solid, right? It's taking up a specific amount of space, right? And it's got a definite shape. Now granted, some of the shape is really, really small, but you can see big clumps of it. And those clumps have a specific shape, and that shape does not change, okay? So solids, anything that has a definite shape and a definite volume. And the thing is, they're solid because the particles are really, really close together, and they also don't move. They don't slide around, they don't move around. They're fixed in position. That's when we think about water when it's frozen. We call it ice, right? Ice has water particles or water molecules, but they don't move. They just sit where they're at in place. Okay? They don't go anywhere. They're just there. Now, if I heat that ice up and I melt it and it turns to a liquid, it still has the same volume, right? But the only difference now is it doesn't have a shape that is definite. The particles are still real close together, but they're not fixed in their spots. They're not stuck there. And I'm going to show you what I'm talking about. Okay? If I take this water right here, which is in this graduated cylinder, right now there's about 78 milliliters of water in here. If I take it and I could somehow remove the graduated cylinder